It begins with a cloud. Not a cloud drifting over an afternoon sky, but one so vast it swallows entire star systems in its shadow. Its edges are a veil of ghostly light, its heart a darkness so deep it feels endless. And yet, somewhere inside, something is stirring. Astronomers call them nebulae, but the name, though beautiful, barely hints at what they are. To some, they are stellar graveyards, where the remains of exploded stars drift like cosmic ash. To others, they are nurseries where new suns are born. The truth? They are both and more. They are the breath of the universe itself, inhaling the debris of dead stars, exhaling the brilliance of new ones. Imagine floating through one. There is no up or down here, no ground beneath your feet, only endless, shimmering filaments of gas and dust. The colors you've seen in photographs are real, but here they aren't still images. They ripple faintly, as though the nebula is alive. And in a way, it is. A nebula is a paradox. Empty space that feels full, silence that hums with energy. If you could stretch your arms here, they would pass through particles of hydrogen that once belonged to stars older than Earth itself. Every wisp you see is ancient history, and yet a promise of the future. Some nebulae span hundreds of light years. A single light beam, moving at the fastest speed the cosmos allows, would take centuries just to cross them. Their size is so incomprehensible that human metaphors fail. But size isn't the only thing that makes them mysterious. It's what they do. Inside their swirling depths, gravity works in whispers. It coaxes hydrogen atoms together, pulling them ever closer. The temperature begins to climb. Particles crash, fuse, and in those collisions something extraordinary happens. Light is born. The faintest flicker becomes a glow, the glow ablaze, and then a star takes its first breath. But here's the twist. Not every nebula is a place of birth. Some are places of death. The Crab Nebula, for instance, is the shredded corpse of a massive star that exploded 1,000 years ago. What remains is a glowing cloud of gas expanding into the void, carrying with it the ashes of a stellar giant that once lit up the night sky. In the universe, endings and beginnings are not opposites. They are threads in the same tapestry, and nowhere is that more evident than in a nebula. The Orion Nebula, perhaps the most famous of all, hangs in the sword of the constellation Orion like a hidden jewel. To the naked eye, it's faint, a smudge of light, but through a telescope, it becomes something else entirely. A swirling violet-blue cloud lit from within by newborn stars. It's as if the cosmos itself painted a masterpiece and hung it in the night. But what you see is only the surface. The real story lies deeper inside. Because what the eye misses, science reveals. Deeper inside the Orion Nebula, the light grows stranger. It doesn't just shine, it sculpts. Rays from newborn stars carve tunnels through the gas, creating caverns of glowing hydrogen. Some regions are bright as embers, others shadowed like ancient caves. Here, darkness isn't the absence of light, it's the birthplace of it. Astronomers peer into these depths with the Hubble and James Webb Space Telescopes, and what they see is almost too surreal to be real. Columns of dust rise like cosmic mountains, some taller than our entire solar system. Around them, waves of gas roll in slow motion, moving so gradually that a human lifetime is nothing but a blink to them. And in their shadows, specks of light glimmer, the seeds of future suns, each with the potential to host planets, oceans, and perhaps life. But how does this transformation truly begin? It starts with instability. In the vast quiet of space, even the smallest nudge can set destiny in motion. A passing shockwave from a nearby supernova, the slow pull of gravity from a cluster of stars, any disturbance can cause a nebula's delicate balance to collapse in on itself. As the gas falls inward, it heats, pressure builds, and the fusion furnace ignites. What was once cold and invisible becomes a beacon in the dark. Yet not all stars survive their birth. Some collapse too violently, ripping themselves apart before they fully form. Others are born in chaotic regions where their siblings' gravity tears at them, slingshotting them into deep space. And some are simply smothered, their light never breaking free. In a nebula, beauty and destruction are inseparable companions. Perhaps the most haunting nebulae are the planetary nebulae, a misleading name because they have nothing to do with planets. They are the final exhalation of dying stars like our sun. As a star reaches the end of its life, it swells into a red giant, then gently sheds its outer layers into space. The result is a delicate, glowing shell, expanding slowly away from the star's remaining core, a white dwarf. These shells can form intricate shapes, glowing rings, butterfly wings, or expanding halos. Each one is a stellar farewell letter written in light. Consider the Helix Nebula, sometimes called the Eye of God. From Earth, it appears like an immense, turquoise iris staring into the universe. In reality, it's the last breath of a star not unlike our own, its outer gases now drifting into interstellar space, destined to one day be recycled into new worlds. This cycle, birth, life, death, rebirth, is the nebula's secret. Stars inhale matter from the clouds, burn for millions or billions of years, and exhale it back into the cosmic sea. The universe never wastes anything. Every atom in your body, from the iron in your blood to the calcium in your bones, was forged in a star and scattered by a nebula long before Earth existed. You are, quite literally, made of stardust. And yet, for all their grandeur, nebulae are fragile. A single burst of stellar wind can tear apart a region that took millions of years to form. In time, every nebula will fade, its gas dispersed so thinly that it disappears into the background of space.
But in that fading lies the seed of something new. Some nebulae don't just glow, they trick the eye, the mind, and even the laws of physics. Take the Horsehead Nebula. At first glance, it appears like the silhouette of a horse rearing up against a backdrop of crimson light. But it's not a solid object at all. It's a shadow, a dense column of cold gas and dust, blocking the brilliant glow of hydrogen behind it. It is, in essence, a cosmic photograph negative, a shape carved by absence rather than presence. Then there are the reflection nebulae, like the ones surrounding the Pleiades star cluster. These don't generate their own light. Instead, they borrow it, scattering the blue starlight from nearby suns the way our atmosphere scatters sunlight to create a blue sky. When you see a reflection nebula, you're witnessing borrowed beauty, light that has traveled unthinkable distances only to brush against dust and scatter into your eyes. But perhaps the most puzzling are the dark nebulae. These are voids so complete they swallow starlight entirely, leaving gaping black patches in the sky. They are not empty. In fact, they are among the densest clouds in the galaxy. Their darkness comes from their unwillingness to let light escape. Hidden within them, stars may be forming, but to us, they remain invisible, secrets wrapped in velvet shadow. And then, there are the nebulae shaped by violence. The Carina Nebula, for instance, is a titanic battlefield of gravity and radiation. Massive stars, some dozens of times the size of our sun, blast intense stellar winds that carve caverns and pillars into the surrounding gas. These winds collide, compress, and sometimes trigger the birth of new stars, only for those stars to unleash winds of their own, continuing the cycle of chaos and creation. In the Eagle Nebula, an iconic image called the Pillars of Creation has captivated humanity for decades. These towering columns of dust and gas rise like cathedral spires, each one incubating newborn stars deep within. But there's a twist. Scientists believe that a supernova may have already destroyed these pillars thousands of years ago. If that's true, the image we see is a ghost, a moment frozen in light that's only now reaching us across 6,500 light-years. The pillars may already be gone, but we won't know for certain for centuries. This is one of the strangest truths about nebulae. What we see is not what is, it's what was. Because light takes so long to travel from these distant regions, every image is a window into the past. Some of the most beautiful nebulae we admire today may have already dissolved into nothingness. And yet, their light continues to drift toward us, like a memory that refuses to fade. Even their colors are a kind of illusion. The brilliant reds, blues, and greens we see in photographs aren't what your eyes would see in person. In the cold darkness of space, most nebulae would appear as faint gray smudges. The dazzling colors come from long exposure photography and filters that reveal the specific wavelengths of light emitted by different elements. Hydrogen's deep red, oxygen's cool blue, sulfur's golden hue. In truth, those images are both science and art. Data made visible, reality translated into beauty. But the mystery deepens when we realize that not all nebulae fit neatly into categories. Some are remnants of stars so unusual they defy standard models. Others are so faint we've only detected them in the last few decades. Their existence hidden until our instruments became sensitive enough to notice their whisper of light. And then, there are the ones we suspect might be out there, but can't yet prove. Some nebulae are fleeting, so rare and short-lived that the universe barely has time to make them before they vanish. One such phenomenon is the Wolf-Rayet Nebula. It forms around a star that is on the brink of a spectacular end. Wolf-Rayet stars are titans, burning through their fuel at terrifying speeds. They unleash stellar winds so strong that they strip away their own outer layers, creating a bubble of glowing gas around them. This bubble is temporary, a cosmic soap bubble that lasts mere tens of thousands of years before the star collapses or explodes in a supernova. In the timescale of the cosmos, that's less than a heartbeat. Even rarer are protoplanetary nebulae, the transitional phase between a red giant's peaceful shedding of its outer layers and the fully developed planetary nebula that follows. In this brief stage, the gas is not yet fully ionized, and the central star is still heating. The result is a glowing, often asymmetric structure that seems to shift as the gas expands. Some appear like spirals, others like hourglasses suspended in the dark. Blink in cosmic terms and they're gone. But perhaps the strangest are supernova imposter nebulae, clouds created by stars that look like they've exploded, but haven't. These massive stars experience violent outbursts, ejecting shells of gas into space without destroying themselves entirely. The Eta Carini system is one such case. In the mid-1800s, It flared so brightly it became the second brightest star in the night sky, only to fade again. The result was the homunculus nebula, two immense, lobed clouds that look like a cosmic hourglass, still racing outward at thousands of kilometers per second. One day, Eta Carini will truly explode, and the homunculus will be swept away in an even greater blast. What's remarkable about all these rare nebulae is how fragile they are. They exist at the mercy of their parent stars, utterly dependent on the energy and winds that shape them. Without constant radiation, their glowing forms would fade into invisibility. And when their stars die, the nebulae vanish soon after, leaving only the seeds of future stars in their place. This impermanence is part of what makes nebulae so haunting. The structures we photograph and admire may already be gone, erased by time before we even knew they existed. We are witnessing moments in the universe's grand story that will never be repeated in exactly the same way again.
But there is one more layer to this mystery, the way nebulae shape not just stars, but the galaxies they inhabit. Massive nebulae act as star factories, and the energy they release, through radiation, stellar winds, and supernovae, helps regulate star formation across entire regions of space. In a sense, nebulae are the lungs of galaxies, breathing life into them and, at times, slowing them down. Without them, the Milky Way would be a very different place. And yet, as vast and complex as they are, nebulae also carry a strange intimacy. The very atoms that once drifted in these clouds are inside you right now. The oxygen in your next breath may have been forged in a long-dead star, its ashes once part of a glowing nebula before being swept into the cloud that formed our sun and earth. You are connected to these distant clouds not by metaphor, but by matter. Long before telescopes, before cameras, before even the concept of space as we know it, humans looked up and saw faint mists in the night. To them, these glowing patches were not clouds of gas and dust. They were God's breath, the milk of a cosmic river, the smoke from celestial fires. The ancient Greeks saw part of the Milky Way as the spilled milk of the goddess Hera. In China, some nebulae were described as heavenly gardens, floating in the darkness between stars. We didn't know it at the time, but we were seeing the same things our modern telescopes now reveal in staggering detail, the cradles and crypts of stars. We gave them names from mythology, animals, and shapes that made sense to us. The eagle, the crab, the horsehead, the rosette. Each name, each story, a way to connect our tiny human lives to the vast unknown. Then came the age of science. With Galileo's first telescope, those faint clouds resolved into clusters of stars, hinting at their true nature. Centuries later, photographic plates began capturing their light over hours and days, revealing details the human eye could never see. And today, with space telescopes like Hubble and James Webb, we can peer not only at their glowing edges, but deep into their hidden cores, watching the birth of stars in real time. But even with all our technology, nebulae keep their secrets. We can measure their size, their composition, even their motion. We can map the way light scatters through their clouds and predict the fates of their stars. But we cannot stand within them, feel the scale with our own senses, or watch their slow dance unfold over millennia. We are still outsiders, piecing together their stories from across the void. And maybe that's what makes them so captivating. Nebulae are reminders of time on a scale beyond our own, of beauty that is fleeting even when it lasts millions of years. They remind us that the atoms in our bodies are ancient travelers, shaped by forces so vast we can barely comprehend them. They whisper that endings are beginnings in disguise, and that the light we see is sometimes only a memory of what once was. One day, our sun will end its life not in a violent explosion, but in a quiet shedding of its layers. It will create its own nebula, a brief, glowing monument to its billions of years of life before fading to a white dwarf. And perhaps, somewhere far away, another civilization will see it through their telescopes, wonder at its beauty, and tell their own stories about it. Until then, we continue to watch. We aim our instruments at the faintest smudges, listen for the quiet hum of cosmic creation, and capture these vast clouds in images that will outlive us. Each picture is a reminder that we are part of a universe that breathes, slowly, endlessly, in and out, through the birth and death of stars. And as you drift off tonight, imagine yourself floating in that breath. No ground, no horizon, only endless, glowing clouds stretching in every direction. Somewhere, a star is being born. Somewhere else, one is taking its final breath. And through it all, the universe is weaving its luminous tapestry, thread by thread, for anyone patient enough to look up. If you enjoyed this journey through the cosmos, consider joining us for the next one. Subscribe, and together, we'll keep exploring the mysteries that lie between the stars, one quiet breath at a time.